So this question has got triangles within the parallelogram, and it's given us an angle and two lengths. Ideally we'd need this angle here, because then we'd have a side angle side triangle, and then we can use the cosine rule or the sine formula to work out the area of this triangle, because the question is asking us to work out the area of the parallelogram. So technically these two triangles are congruent, so if we can work out the area of one of the triangles and double it, job done. But to use the general triangle formula for area, so a half AB sine C, we need a side angle side triangle. So in other words, we need an angle theta between a side and a side. We don't have that yet. So this question's kind of shouting out at us, we need to do something to work out this angle here. What we can see though is that we've got a side length opposite an angle, and we've got a side length opposite another angle. So this angle is what we want, but if we can work out this angle, then we've got a triangle, and angles in a triangle add up to 180 degrees. So because I've got side length opposite angle, that tells you to use the sine rule. So basically the sine rule says, now we're using the letters A, D and C for this one, so the sine rule says, because I want an angle, I'll put that on the top. So the sine of the angle A over the side length of A is going to equal the sine of the angle at D over the length of D. Now the length is always opposite the angle, so in this case D will be 9 centimeters, because that's opposite the angle D. Little a will be 11 centimeters, because it's opposite the angle at A, and the angle of A is 100 degrees. So a good habit to get into is define all the letters and find their lengths, and then we know that the missing thing is the angle D. So basically we've got to rearrange this to work out the angle D. So we're going to say that the sine of D, take the little d over by timesing, because that says divide by d, so move it over by timesing. So the sine of D is going to be the sine of A times little d over little a. Because I want the angle of D, then of course we want the inverse sine. So D is going to be the inverse sine of the D number times the sine of the angle A divided by the length of A. Now we've got all our numbers here, so we can put that in. So sine to the minus 1. Alright, so little d was 9, the angle A was 100 degrees, divide by the length of A, which was 11. So we get our calculator, making sure it's in degrees mode. So we've got second function sine to the minus 1 bracket of 9 times the sine of 100 divided by 11, close bracket, equals. So that gives us an angle of 53.68 degrees. 53.68 degrees. Now this isn't the final answer, so actually I'm going to be writing a bit of that down to get the accuracy there. So 53.6829 degrees. So we now know that this angle here is 53.68 degrees. So therefore the angle we want to use in our side angle side triangle here, this one here, can be found by, so we can say the angle at C is going to be 180 minus the 100 minus the 53.68. So if I store that in A and then do 180 minus the 100 minus recall the value we stored, so 26.32 degrees, so 26.317 degrees. Keep a bit of accuracy there until we get to the end. Okay, so we know the angle at C is that, so we now know that this angle here is 26.317 degrees. Now the formula for the area of a triangle says that we take half times the length of A times the length of B times the sine of C, when we've got a side angle side triangle, where that would be C, that would be the angle, this would be A and B, so this would be little b and this would be little a. Now when we look at this, we're going to use side angle side, so we're going to use 9, 11 and 26.3. So for us it's going to be a half times 9 times 11 times the sine of the angle between those two numbers, which we worked out to be 26.317 degrees. Okay, so that gave us 0.5 times 9 times 11 times the sine of 26.317 degrees equals, so 21.945, and this is talking about centimetres squared. So that's the area of triangle ADC. So ADC is just half the parallelogram, so therefore we have to work out the length, twice that. So the area of the parallelogram is equal to 2 times 21.945, so times that by 2, so 43.9 to 3 significant figures, 43.9 square centimetres. So the answer here, 43.9 square centimetres. Okay, so the key to this question then was to recognise that the area formula for any triangle needs a side angle side triangle. We had two sides, ideally we want the angle between them. We didn't have that straight away, so when we looked at the information we could see that we had an opposite length and an angle, and an opposite length and an angle. That kind of tells you could use the sine rule to work out this angle, and then we knew that angles in a triangle are to 180. So the sine rule is at the front of the exam paper, so we used the letters that's in the triangle to work it through. Because we wanted an angle, it was easy to put the sine of the angle on the top of the fractions. If we wanted a length, we'd have written them the other way around, so it would have been the little letter on top of the sine and so forth. We then define the value of the letters from the information in the picture. We then rearrange the sine rule accordingly to get the angle, and then once we knew the angle we can then use the area formula to work out the area of half the parallelogram, and of course then we just doubled that to get the final answer for the whole parallelogram. So that's the use of the sine rule and the area of any triangle.